the previous videos, we discussed about the history of Doppler effect. Today's topic is Doppler effect for sound and light energies. That is sound energy. Sound energy is a form of energy which gives us sensation of hearing. It is a mechanical wave. Light energy, it gives us ability to visualize the things, visualize the world. That is why it is called electromagnetic wave, which has oscillating electric as well as magnetic fields. Okay. Now, talking about Doppler effect for the sound energy. This is the diagram which has observer A and observer B. Car is heading towards east. Now, tell me one thing. Which observer will perceive more louder sound? Of course, the answer is observer B, right? Because observer B is relatively nearer as compared to A. That is why, as nearer the source is to the observer, more frequency is heard. That is why more frequency heard by observer B and less frequency heard by observer A. Now, since the frequency is more in the case of observer B, so wavelength will be less, right? Because frequency and wavelength are inversely related. So that is why lower wavelength, high frequency for the observer B and high wavelength and low frequency for the observer A. This shift in perceiving the sound energy of the two observers is called Doppler effect for the sound. Got it? So, the definition is apparent shift in the frequency of wave in relation to observer moving relative to wave source. This is called Doppler shift for the sound. Now we are talking about Doppler effect for the light energy. So light energy, when it is said, the first thing which comes in our mind is Vibgyor, the spectrum of, or you can say band of 7 colors, right? So two main processes, violet shift and red shift, are observed here. When the distant star is approaching the earth, you say the process is violet shift. When the distant star is moving away from the earth, you see red shift. Yani ki, when the star is moving towards the earth, you see the spectrum is moving towards violet end of the spectrum. This is the spectrum diagram. So this is the violet end. And when the star is moving away from the earth, or any distant star is moving away from the earth, you observe that spectrum is shifting towards red end. That is red shift. And this is all about Doppler effect for the light. Okay. Now what is the significance of Doppler effect for the light? Hubble observed this and deduced two main points. First point is expansion of universe. This shift is giving you the information about Big Bang theories, right? That is, universe is expanding. If suppose this square is the universe, this is the earth and this is the star, and the star is moving away from the earth, the more it will move, this universe has to expand, right? So that is why, so that it will accommodate these two particles, earth and star as well as. So that is why expansion of universe, it is explaining this concept, laying down the foundation of Big Bang theory. The second point is Hubble's law, that is V is equal to h naught d, where V is the velocity, h naught is the Hubble's constant, and d is the distance between source and observer. Okay. So this is about two main significance of the Doppler effect in the light. There are more applications, we will discuss it later.